Dun, 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 dun. Your mission, should you choose to accept it, or really should you choose not to accept it, because you got to take exam 1, is to be ready with all the vocabulary that you need. We started with statistics as the first definition. It is the name of the class. And a statistic versus parameter. Statistic comes from a sample, and as such it has error based off who you randomly select in the sample. The parameter is the true value for the whole population. What kind of data are you collecting? It could be categorical or numerical. And if we wanted to draw the data with a picture, we might use bar charts or pie charts. And that's almost about as far as we went with categorical data. The rest of our time we spent looking at numerical data, for example, histograms and box plots. And you should be able to look at a histogram, and then typically by elimination, you can figure out which box plot matches that histogram, or be able to go back and forth on those. How do we get that box plot? It's going to be with the 5-number summary. That's the minimum, Q1, median, Q3, and maximum. It's a nice way to be able to draw the box plot. Speaking of median, that is one of our 3 ways to look at the center of a distribution. The mean, which is the equation sum of the xi's over n. And sum of the xi's means we're talking about data. So this is adding up all the data over n. So we're talking statistics and sample right here. We'll get over to the population side in just a minute. Median is that middle value. If you counted, make sure it's sorted in order first. Mode is the most frequent. If we talk about spread, then there's 4 things that we talk about, although standard deviation and variance are really about the same thing. IQR has an equation, Q3 minus Q1, but honestly, I probably never use that equation. I just think to myself, how big is the box part of the box plot? That's IQR. Range, of course, is from the maximum to the minimum. And if you have a question like this, the first thing you're going to want to do is take all that data and sort it in order, and then you can find minimum, maximum, and IQR. Standard deviation is a little more tricky, and I really think the equation doesn't help you unless you've done it before. I like to list all my xi's and then list all the xi minus x bars. And on an exam, you won't see 50 data points. There's just not time for that. So, 3 to 6 data points is really all you can do in that amount of time. To do the variance, it's just going to be the standard deviation squared. So these were the first definitions we did. The next chapter delved into probability. Probabilities, of course, have to be between 0 and 1. And at the core, what a probability tells you is how many ways something could happen over the total. So for example, we worked with probabilities for A and for B, and sometimes we talked about probability of A and B both at the same time. Maybe it's A or B, and it could be A given B. Some of these were simple enough that we could actually just add up the number of ways it could happen over the total. Sometimes we used equations, but keep in mind this equation did require that independence assumption. Sometimes if it's not independent, you can just tell by the scenario, like A and B can't both be happen. So the probability of A and B is just 0. Or if A happens, B has to happen. Situations like that. So this equation here also uses probability of A and B. You've got to be able to solve this if you want to get the OR statement. Probability of A given B. Some ways to solve this, for example, are that use the tree diagram or counting method or Bayes equation. They're really just the same thing of trying to draw out what probabilities you are looking for. These questions also can go really well with a contingency table, where you have some categories, rows, and columns, and these tables were filled with values, and then you would ask questions for probabilities, and it could be and statements, or sometimes given statements, and you would use the table to find those probabilities. Then we talked about how would you calculate certain things if you knew the whole distribution. We had the discrete side and the continuous side. If you wanted to find the expected value of x, you would add up x times f of x. That's the first moment, also the mean. And we're not talking about data here. We're talking about having the f of x, which is for the whole parameter. So that's actually mu that we're calculating with that first moment. Here, the second expected value. The reason why that's useful is it's a good tool to help us to get the standard deviation. You could calculate higher moments if you wanted to. The median, you add up till you get to 0.5. For the capital F of x, that's instead of being the PDF, the CDF, well, then you add up those probabilities as you go along. To flip to the continuous side, it's the same idea, but we're replacing the summations with integrals. For the median, you want to integrate up to 0.5. So you could just use the CDF because that's the point of using the whole CDF. We also talked about how do you calculate probabilities when it's just an f of x. But what if it was a three-dimensional probability? Well, you would calculate a integral across x and y. The z-axis now is what probability is. You could do more if you want. I mean, the math isn't hard. Just that idea is really all you need. The moment generating functions, those were where you take derivatives and then set t equal to 0 to get moments. The first moment, you take one derivative, set t equal to 0. If you want the second moment, you take two derivatives, set t equal to 0. Third moment, three derivatives, set t equal to 0, so on and so forth. We also talked about a couple of distributions where you should know their name because they're useful in real life. The normal distribution is used a lot when you're talking about a target value and there's error causing it to fluctuate around the target, but you're hoping to be as close to target as possible. Log normal is often used when you're wanting probabilities for a growing model. What's the probability it grows a certain amount within some certain amount of time? The Weibull distribution is when you're not talking about the average or the expected, but the maximum. What's the most extreme value that could happen? For all of these, infinity is what could happen. A growth model could expand to infinity. I mean, the probabilities get smaller the bigger you get. Weibull, the biggest, it's not like there's a limit. It could be infinity, but small probability. Or you could be off target by infinity. Beta is not. Beta is restricted. For instance, between 0 and 1. So it's useful for probabilities of a proportion because there's a maximum. It could be everyone, but that's as most it can get. It can't go up to infinity. The exponential is waiting time. So you could wait an infinite amount of time. I mean, the probability is small, but how long do you have to wait for something to happen? The gamma distribution says, how long do I have to wait for several exponential things to happen? So you take several exponential things in a row, that's what gives you a gamma. And then out of all of these, it's the normal distribution that we're going to want to use for a few months. So get used to that notation, the mu and the sigma squared, drawing the picture. Here's mu, sigma squared, as an x value, and you want probabilities, which is the shaded in region. You should be comfortable with the definition of a z-score. Yeah, here's the equation. Don't memorize the equation until you understand this is how many standard deviations away you are. That's important for what we're going to be doing for the whole rest of class. And then from there, we can calculate probabilities less than 7, greater than 7, greater than or equal to 7. Spoiler alert, that's the same thing.
Spoilers.
We could do probabilities for between some range. We could also say given the probability. Maybe it's the top 10%. Maybe it's the 90th percentile. Second spoiler alert, that's the same thing. So can you find the x value for those percentages? This one's called the z-bridge. A has some distribution, B has some distribution. If I give you the value of A, can you figure out what it would be on the B distribution?
Thinking B! Thinking B!
So if A is 14, then it's one standard deviation above the 12. So one standard deviation above the 20 would be a value of 20. And watch out for sneaky things we can put on this test. One sneaky thing is to have really small z-scores. Because when the z-score is between 0 and 1, it looks like a probability. But it's not. Z-score is distance. Probability is area. So watch for that trick. Or what if you get a z-score that's just massively huge, like 12? What does that even mean? How do you put that into the applet? Well, if you understand what z-scores are, being 12 standard deviations away, you're like, oh, I don't even need the applet. I can tell you the probability just based off that. But those are the kinds of tricks that are pretty common. This concludes what we have done so far. Now you should be ready to look at those practice exams and see what areas you need to brush up on.